Okay, in this video I'm going to go over the first problem from your phase diagram crystal structure worksheet, step by step showing you how to sketch the phase diagram for oxygen. That means dioxygen O2 using the following data. Triple point 54.3 Kelvin and 1.14 torr as the pressure. Critical point 154.6 Kelvin and 37,826 torr. And then, of course, the normal melting point and the normal boiling points, which are given. The first thing we're going to do is sketch the x and y axes. For the diagram, temperature will be on the x-axis and pressure on the y-axis. And I've added in the units that were given in the data above. Now, the scale for these is going to be a little bit rough, but essentially for the temperature, we have a range of 54.3 Kelvin up to 54.6, right? And then the normal melting point in Kelvin is 54.4 K, so it's around the same temperature as the triple point. And the normal boiling point in Kelvin is 90.2 K. So I have a range from 50 K up to 150 K or so. So I'm going to go in 50 K increments on my x-axis, roughly. The pressure has an even larger range to deal with. The pressure is starting at 1.14 torr and going up to 37,826 torr. That's a large range, through 760 torr, which is the pressure for the normal melting point and normal boiling point. So I'm going to use a logarithmic scale for the y-axis. So in other words, 10 to the first, which is 10, 10 to the second, which is 100, 10 to the third, 1,000, 10 to the fourth, 10 to the fifth. That will allow me to get the whole range on the scale without having to go way, way, way off of this paper. Okay, now, first, the next thing we're going to do in constructing the diagram is to put in the data that they've given us. So put in points for the triple point and melting point and boiling point and so forth. So I'm going to start by writing a line in at 760 torr and then sketch in a point where approximately the normal boiling point should occur at 90.2 K and 760 torr. So I'm going to go along that blue line. I'm going to find around 90.2 K on the x-axis and sketch in that point. Then I'm going to do the same thing at a point for our normal melting point, which is at 54.4 K and 760 torr. So I would put in a point there, just like that. And probably I should go ahead and label those as the boiling point and the melting points. Next, I'm going to add in my triple point, which is at 54.3 K and 1.14 torr. So I'm going to put in a line to indicate 1.1 torr. That's pretty rough, actually, but it'll be easier to see it above the black line of the X scale if I put it up a little bit higher. Now I'm going to sketch in that point 54.3 K at 1.1 torr, which is the triple point. And then finally, let's add in the critical point. Critical point is at 37,826 torr, so I'm putting a rough estimation of that pressure, and then I'll put in a point at around 154.6 Kelvin, roughly. There we go. Now all our points are in. Now, you have to remember what the phase diagram represents. It represents phase changes at temperatures below, to the left of MP, the melting point. Oops, I forgot to put in my label for critical point. There we go. At temperatures below the melting point, we should have a solid. At temperatures between the melting point and the boiling point, we have a liquid. And then above the boiling point, gas. Okay, so I'm sketching those in so I have a rough idea of where the phases are. And now it's a matter of connecting the points. I've added in a blue dot to represent the zero pressure that would occur at absolute zero. And I'm simply going to draw a line connecting that dot to the triple point, like so. And it should be sort of curved upward. Now, the next part is to draw a line that goes through from the triple point up through the melting point and then sort of on as high as we feel like drawing it, like so. So now I've defined the boundary between solid and liquid. Now we need to define the boundary between liquid and gas. To do that, we're going to go from our triple point, right, up to the boiling point and through to the critical point. And there you go, and we're done. And so if you follow this procedure with a given set of data, you can do this for any particular compound that you would like to see a rough phase diagram for. And that's it. Now we can play with the phase diagram. You can imagine that if you have oxygen at 10 torr and say 25 Kelvin, and you begin to raise the temperature up past 50, you'll first go into the liquid phase, and then if you keep raising the temperature, you go into the gas phase, right? And so there is our phase diagram for oxygen. Okay, great.